fx and fy. We are given a vector 1000 Newton inclined at angle 30 to the horizontal. I asked to find fx and fy. What do? It's very simple. We are going to use resolving vectors into component. So our fx is equal to f cos theta. Anytime you are asked to resolve a given vector to a horizontal component, what you simply do is to multiply that given vector by cos of the angle of inclination between the vector and the horizontal component. So fx is f cos theta. So we are going to have that fx is equals to, what is f? F is 1000 Newton multiplied by cos, what is the angle of inclination? Cos 30. This is going to give you fx is equals to 1000 multiplied by cos 30 is equal to 0.8660. So by the time you multiply this, you have your fx is going to be equals to, this is 30, we're going to have 3 zeros. To move this into 3 decimal 3 places, 1, 2, 3. That will give you 866.0 Newton. So the fx is 866.0 Newton. Then to find your fy is going to be equal to f sine theta. Remember, anytime you are resolving a vector into a vertical, you are resolving a vector into a vertical component, multiply the vector by sine of angle of what? Inclination of the vector to the horizontal line. So this fy will be equals to 1000 times times sine 30. Fy is equals to 1000 multiplied by sine 30 is what? 0.5. This will give you fy is equals to 0.5 is the same thing as 1 over 2. 1000 multiplied by 1 over 2. So fy is equals to 500 Newton. So you have got to your fx and fy. Fx 866.0 Newton and fy is 500 Newton. Please don't forget to like this channel. Don't forget to like this video. Share it to your friends. Don't forget to like this video. Drop your comment in the comment section. Subscribe. I have a question like this. The question says you should find the tension T in the ropes. So this is a bag and they are using, there's a rope which is the hand of the bag that is used in carrying this bag. So if you are carrying this bag using the ropes, these two ropes here, the question is you should find this tension, that is the force that is on the ropes. So the first thing you need to know here is that if you watch the angle of inclination of each of these ropes to the vertical line is 70. That goes to tell you that the tension T in this rope is equal to the tension T in the second rope, because they both have the same angle, since the angle they have there is 70 degrees is equal to 70 degrees. So the tension in the two ropes is going to be equal. Whatever tension that is found in this first rope will be found in the second rope. Then, how do you solve this problem? This problem can be resolved by using a triangle method of vectors, because these three vectors are in equilibrium. And what are the three vectors? The three vectors include, one is the weight of this object acting downward, then the force on the first rope and the force on the second rope. So we can represent this thing in a triangle. So we can represent the weight of this object acting downward by a tiny line. This tiny line now is the weight of this object. And remember that weight is equal to mass times acceleration due to gravity, which is equal to 6 6 times 10. If we take our G to be 10 meters per second square, so we have our weight to be 60 Newton. So what we have here is 60 Newton. That's the weight of the bag. Then we are told that the first rope is inclined at what angle? At angle 70 to the what? To the vertical line. You can see the vertical line. So, and this force here is a vertical line as well. So the first force is inclined at 70 degrees. So this is my T. And the second one is also inclined at 70 to the vertical. So this is another 70 here. So this is my T as well. So having done that, we can find the angles inside this triangle. For 70 plus 70, the angle inside the triangle is going to be 180 minus 70 plus 70, which is equals to 180 minus 140, which is equal to 40. So this side, the angle here is 40 degrees. Then if you look at this triangle, we say that this triangle is what can be called an acute angle triangle. Why? Because none of the angles here is equal to 90 degrees. So it is an acute angle triangle. If this is an acute angle triangle, what is the best way to solve it? What you simply do is you use the sine rule. So I'm going to use sine rule here to resolve the problem. And I hope you still remember how sine rules are written. Sine rules are written as A over sine A, capital A, to be equals to B over sine capital B, to be equals to C over sine capital C. If I label here to be A, B, and C, so I will apply this formula there. I want to start immediately. So I'll pick A here. The side facing this angle A is T. So I say T, which represents my small a, divide by sine of that A, which is sine 70, must be equals to B. The side facing B is 60 Newton, divided by sine of the angle facing the 60, which is sine 40. To make T the subject, I'm going to have T times this, T sine, that is 87 Newton. So the tension in the ropes, T here is 70, this other one is also 70. Don't forget to like this video, and please share this video with your friends so that it will get to many students. A bag is hanged as shown in the diagram using two ropes. So one is tied to one side to the wall. The other is also tied to the other side of the wall. So you discover that the two ropes are inclined at an angle of 60 to the what? To the wall, which is to the vertical line, because the wall now serves as a vertical line. The two are inclined at an angle of 60 to the vertical distance. So the two ropes are inclined at angle 60 to the wall. So in resolving this, you should also know that T here, the tension in the first rope is also equal to the tension in the second rope, because sine 60 is equals to sine. The tension in the first rope is equal to the tension in the second rope. The tension in the first rope is equal to the tension in the second rope, because sine 60 is equal to sine 60, because both ropes are inclined at the same angle to the wall. So now we can resolve this as well by using triangle method of vectors. are in equilibrium and they can be represented in a triangle. So the first is, we are told that the weight of the bag is 2 newtons. So we use a thin line. This thin line now represents the weight of the bag, and it is acting downwards, which is 2 newtons. Then we are told that the ropes are inclined at 60 to the vertical. So 60 here to the vertical and 60 here. So this is 60, this is 60. This is my T, this is the second T. Then it is a burden on you to find the angle, the third angle in that triangle. So the angle in that triangle is going to be 180 minus 60 plus 60, which is equals to 180 minus 120, which is equals to 60. So the third angle here is 60 degrees. Now, what type of triangle is this? This is an acute angle triangle. And this acute angle triangle can only be resolved using sine rule. So we are going to make use of the sine rule here to resolve this problem. And in making use of that sine rule, you already know the rule. The rule says A over sine A equals to B over sine B. So let me say that this is A, B, and C. Then I'll pick the A. This capital A is facing here, so it's T over sine 60 to be equals to B. B is 2 newton over sine 60. So we have to make T the subject. T sine 60, that's this times this, is equal to 2 sine 60. So you divide both sides by sine 60. So this sine 60 cancel this. I'm left with T equals to sine 60 here, cancel this. I'm left with T is equal to 2 newton. So the tension in each of this rope is equals to 2 newton. Don't forget to like my video. Please share this video. Keep sharing this video until it goes viral so that many of our students will see this video. Thank you.